歡迎收睇傳媒對焦。極光係不可思議嘅宇宙現象，觀賞極光成為旅遊精選項目。其實極光係太陽風暴侵襲地球所造成，伴隨太陽風暴就有地磁暴破壞地球嘅電力供應、GPS、手提電話等嘅服務系統。科學家係點樣應對隨時會發生嘅宇宙極端天氣呢？現今嘅科技有冇可能追蹤到太陽風暴幾時抵達地球，做好準備保護電子通訊等科技設施？
地球南北兩極同緯度較高嘅地域都會見到五彩繽紛嘅極光。本國係最常見到極光嘅國家之一。
Canada is located in the high latitude region, and this is basically a good place to see aurora and all those northern lights things, auroras.
極光嘅成因伴隨太陽風暴侵襲地球所引發嘅地磁暴，不可思議嘅視覺盛宴背後就隱藏宇宙間可大可小嘅禍根。單係大家習以為常嘅供電、全球定位系統 GPS 以及手提電話服務，都可能因為太陽風暴而長時間中斷，對社會民生造成巨大影響同損失，令人不寒而栗。
We don't have comprehensive solution yet. It could happen anytime. So this is why we need to prepare. Because the modern society these days highly rely on basically the advanced technologies. First of all, this is power system, which is the backbone of all this new society. And the solar storm effect power system, society is relying on communication, a global positioning system, GPS, and all of these things. And all of these could be affected by solar storm. So we didn't have that dependency in the past. This is why today's society is more vulnerable than the past.
乜嘢係太陽風暴？乜嘢係地磁暴？同極光之間有咩關係呢？太陽突然爆發嘅活動喺日地空間引發一系列強烈擾動，就係太陽風暴。當太陽風暴襲擊地球嗰陣，會擾亂地球磁場，就係地磁暴 GMD。地磁暴係太陽巨大日焰所產生太陽風震波或者磁雲同地球磁場交互作用所引致嘅地球磁層擾動。
Because we still don't know all the aspects of the solar storm. And this is why we need to do a comprehensive research like what we have in my research team at York University to basically model, analyze the phenomena, better understand it, and better understand and model the impacts, and try to develop a comprehensive solution and effectively mitigate those effects in power system, which is my main field of study and research.
而極光係由嚟自磁層同太陽風暴嘅帶電高能粒子，俾地磁場導引帶入地球大氣層同高層大氣嘅原子碰撞造成嘅發光現象。
This is because of the fact that in addition to geographical poles, it has also geomagnetic poles. These charged particles that create those aurora are injected into the geomagnetic poles.
太陽風暴喺地球表面嘅長距離導體設備上可以激發地磁感應電流，簡稱 GIC。佢嘅影響甚至能夠破壞高壓輸電網以及所連接嘅變壓器或者輸油氣管道或者火車路軌，造成城市營運癱瘓以及經濟損失。隨住科技發展，中緯度地區嘅電網規模以及負荷增加，近年亦容易受到 GIC 嘅擾動。
The solar activity has 11-year cycle. So once we get to the peak of the activity, we expect more solar storm. But this is a kind of, again, a probabilistic phenomena involved here.
就係剛啱過去嘅5月中旬，歐美、中國北部以至南半球嘅澳洲同新西蘭等地都見到絢麗璀璨嘅極光。呢次係20幾年嚟最強威力嘅太陽風暴所導致。
The solar storm and space weather is mostly affecting the high latitude regions. And because Canada is located in this region, so we expect Canada will be one of the countries that see the solar storm effect the most.
今次太陽風暴造成嘅地磁暴被評為最強嘅5G 級，所衍生嘅電流劇烈波動，影響地球嘅通訊、廣播同導航定位。
This is a general notion is that the higher latitude region is more exposed to the effect of solar storm. But the recent event that happened, for instance, in the last May, it showed the opposite. So the magnitude of GIC that we observed in the US in power system at least was higher than what we observed in Canada. And this is interesting. It means the existing basically notion and just the rules that we typically say is not 100% correct sometimes. We need more research to better understand it and come up with more accurate models and methods.
地磁暴引發嘅太陽質子事件，干擾無線電同雷達嘅電離層擾動，仲有導航使用嘅羅盤，除咗通訊同電力中斷，亦都喺極區產生燦爛嘅極光，情況會持續幾小時甚至幾日。
Because we want to prevent equipment failure and collapse of our system. So based on that, we want to identify the weak points, weak elements, do some corrective actions, maybe taking out of service temporarily and bring in service again after the basically a storm, or developing some operational procedures to minimize the effect.
歷史上有記錄嘅最強威力地磁暴係發生喺1859年9月嘅卡靈頓事件。英國天文學家卡靈頓觀察同記錄咗太陽嘅白光閃焰、太陽嘅日面物質拋射撞擊地球磁場，以17.6小時完成咗1億5千萬公里嘅旅程，相對一般情況需要幾日時間先能夠抵達地球，可想而知威力係超級強大。
In the past event, the Carrington event, for instance, it was one of the most severe one, which is a kind of benchmark for those solar storms these days. And we typically want to compare and study the effect of such a big storm on infrastructure if it happens today. What would be the effect? And so we need to basically improve and basically protect our infrastructure against such strong events.
乜嘢係日面物質拋射 CME 呢？呢啲係太陽從日面釋放大量電漿同磁場進入日球層嘅現象。CME 到達地球磁層並且同佢碰撞，隨即引起地磁暴。1859年嘅 CME 擾亂當時新創建嘅美國電報網絡，部分線路癱瘓，甚至引發火災。同時世界各地出現強烈極光，連中美洲同夏威夷都睇得到，持續接近1個星期。而本國魁省就喺1989年亦都受到嚴重地磁暴侵襲。
It caused the blackout of the complete power system in Quebec, left 9 million people for 8 hours without power. There were a number of failures reported in power system in Canada and in the US. More than 200 maloperations were reported in Canada and US in only power system.
2003年10月，地磁暴亦都令到瑞典大停電，全球定位系統同衛星受到衝擊。
In 2022, one day after launching 49 Starlink satellites, 40 of them out of 49 just collapsed, crashed into the atmosphere due to that solar storm that happened. So it affects different technologies in different aspects.
加拿大自然科學與工程研究委員會係聯邦政府1970年代創立並且專門撥款俾大學做科學研究嘅機構。約克大學最近獲得佢哋資助165萬元，透過佢哋嘅協作研究及經驗培訓嘅計劃，俾學員參與現代社會和科技基礎設施嘅地磁擾動 GMD-MSTI 項目。跨行業以及跨學術機構攜手開發先進嘅建模同分析技術，嚟評估地磁擾動 GMD 對關鍵科技基建嘅影響。
This program is funded by Natural Sciences and Engineering Research Council of Canada, NSERC, and basically led by myself at York University in collaboration with 3 other universities, some other companies, and also government institutes like Natural Resources Canada and National Research Council of Canada, NRC, that basically involve different field of engineering, including power systems, satellites, communication, biomedical engineering, also some fields from science, also policy, disaster management, and basically emergency response.
呢項計劃初步為期6年，培訓不同領域嘅新一代科學家，大概53人，包括本科生以至博士生。目前大概有10間合作企業，俾學生喺工作崗位實習。除咗喺課堂同實驗室嘅鑽研，亦都同其他3間大學聯手喺幾個地磁觀察場進行測量。
Because the phenomena start from sun, then comes to the earth, the magnetic field and geophysics and the earth science will be involved. Then the effect will be in the engineering side. Improving the resilience of power system and safely operating power system through the storm. When it comes, we need a number of, let's say, prediction, preparation, and all of these things. So what we are working on in my research team at York University is to develop a real-time simulator for the solar storm. In real time, based on the data stream coming from the magnetometers and the real-time measurements.
GMD 令到大家時刻都唔能夠離開嘅科技系統遭受骨牌效應嘅損壞，後果會係災難性嘅。本國早已經將地磁擾動納入國家風險類別之內，但係應對太陽風暴係具跨學科、跨技術領域嘅複雜性。上述計劃希望能夠滿足國內同國際最迫切嘅需求。
In real time, in control room of our system, operator can look at basically the output of this program and make a timely decision how they want to operate now, from now to 10 minutes later or so on, how to operate system through the storm without any problem. This is real-time calculation and showing the real-time situation, plus some prediction for the near future.
地球係得天獨厚嘅星球，如果冇南北兩極形成嘅保護性磁力屏障，就無法抵擋嚟自太陽嘅致命輻射。呢個微妙而複雜嘅相互作用所幻化撲朔迷離嘅極光，預示緊宇宙極端變化嘅威脅隨時存在，亦都證明咗脆弱嘅地球正係得到防衛盾嘅強力保護。
各位如果想重溫以上節目內容嘅話呢，可以去到本台嘅網站，點擊節目重溫裡面嘅傳媒對焦就可以啦。再會。